Hello and welcome back to Steaming with Steve. Today we're going to unpackage how functions work inside of Python. Now we've done this before when we've been looking at inbuilt functions inside of Python, such as the print statement, where you type print and then you type the different strings that you want to output. We're going to learn today how to build your own functions that allow you to sort of take on what already exists and then extend it so that you can reuse it. So let's jump on in. Now you don't need to understand this function. This is just so that you've seen what one looks like. And we'll just talk about some of the key words here. So the most important thing when you start a function always has def at the start. So def means that the function is defined. Then you have the name of the function. So in this case, it's round. Then inside the brackets, you have a thing called the parameter, which is the value that's been inputted into the function. And then a snaky bite or a colon at the end to signify that the function is now going to be defined. Afterwards, you have all the different technical ways of getting the function across the line. And then some functions have the option of having a return value, which then means the value that's going to come back from this function. So let's have a look and unpackage the different things that we need to understand. So the learning intentions for today, you need to understand and define what a function is in Python. We're going to learn how to create and use functions for basic calculations and tasks. Apply the concept of functions to solve some real-world problems, and then develop a function for rounding numbers and then converting temperature units. So how do you round a number to a whole number? Well, it's pretty easy. So first of all, you look at the number to the left of the decimal place, or that first decimal place. If the digit is less than 4, is 4 or less, the integer part of the number stays the same. Otherwise, or else, you add 1 to this integer part of the number. That's it. So that's a little algorithm to describe it. So let's sort of see that in practice. If you had 25.7 and you were trying to unpackage that, this is what would happen. So you would look at the 0.7, so the 7 in that, and then you'd have to determine whether or not it becomes 25 or 26. Now, because 7 is greater than 4, that means it would then go up. So therefore the number is rounded up and that bit of code is executed. So where it becomes 26. So the question would be, what is a function? So a function is a procedure or a routine that automates a process. So it basically makes your life easier when you write a function. It encapsulates the performance of particular operations so it can be used by others. So for example, the round function we just talked about. It can either have an input or no input at all. It must be describing an action or a set of actions that need to occur. And then it can, so it's optional, return an output. So that means a value comes back from the function. So I always like to think of a function as sort of a black box where inputs come in and then the output gets generated from it. So you might think of a good old sausage maker. So the meat goes into the sausage grinder, gets grounded down, and then out comes the sausage at the end. So with the round function, we would have a value that's been inputted. That's what goes in. It then gets checked to see whether or not the value at the first decimal place is less than or equal to 4. If that's true, you just return the integer part of the value. If it's false, you go the other way and you return the integer part plus 1. So why do we bother using functions? Well, they're super handy. Basically what happens is you have, like you can see here, this is a cubing function. So the inputs are the different numbers that you can put in, and the output is just that numbers cubed. It's a pretty simple one. So what happens is it allows you to give an abstraction of an operation. So if you've got more complex things, it allows you to describe it in a meaningful, sort of simple way that you can comprehend. You can then reuse the function. So once you've defined it, you can then use it as much as you want throughout your program, which is really, really useful, particularly when you start building your own games. You can then share it. So if you build that particular function that has this input and this output, it allows you to share that with others so then they don't have to rewrite that bit of code, which is really handy. It simplifies the code, so it makes it more readable. So when you pick up the code, you can understand what the intention is. And then, yeah, that's pretty much it. So we're going to have a look at a real world function in the next clip from Wally. There's a whole heap that happens. So for example, Wally is moving E would be considered a function. The captain moving the chair around the control room, again, would be considered a function. So have a look and try and write down as many as you can. fast. Function is recognized. Elevator's closed. There's another function. Guard goes back to work. Elevator shooting all the way up to the top. Ollie's looking around, trying to sort out what's happening. Moves forward. Doors closed. Then scanned by a robot. He's then scanned. Determine what the key is.
Captain, you are needed on the bridge.
Now Wally's in the captain's room. So the captain's room lights are coming on. Wakes up.
No.
Lots of world.
All hands on deck!
Morning. Just a tramp?
Captain goes,
Fine adventure.
"Take it."
Uh-huh.
Wake up.
Oh, I see. I know, honey, I know.
Wake up.
I'm good. I am good. You look
That's all.
gorgeous.
Gets dressed. Has a quarterback. Elevator goes up. Door opens. Coffee gets made.
Sir,
Coffee.
sir, the animal.
Protocol, Otto. First things first. Computer, status report. Mechanical systems,
Unchanged.
reactor core temperature,
Unchanged.
passenger count,
Checks to
Unchanged.
see if
regenerative
we've
food
got one.
buffet,
Unchanged.
jacuzzi pH balance,
Unchanged.
atmospheric conditions, counter service volume.
Unchanged.
Okay, Otto.
Sir, the animal reconnaissance.
12:30? Otto, why didn't you wake me for morning announcements? Honestly, it's the one thing I get to do on this ship.
Here's the change. Umbrellas from around this train stop.
Well, good morning,
Yes, thanks.
everybody, and welcome to day 255,642 aboard the Axiom. As always, weather's a balmy 72 degrees and sunny, and oh, hey, I see the ship's log is showing that today is our 700th anniversary of our 5-year cruise. Well, I'm sure our forefathers would be proud to know that 700 years later we'd be doing the exact same thing they were doing.
Oh,
So, be sure next mealtime to ask for your free Septuacentennial
That's
cupcake
the
in a
word.
cup. Wow,
Spelled
look
out
at
to
that. Also today we have a... hey, Otto, what's that flashing button?
yeah. So that should have given you some ideas of what happened. So what functions did you see behind the scenes then? There should have been a few that you should have popped out from the display. So I made a list myself of a couple that I saw, and you might see something different. So I first saw the door open, Wally moving the tray, security robot typing, elevator going up, Wally looking around, control robot scanning Eve, control robots walking captain, turning on all the lights in the captain's room, music in the room starts playing, 2 grooming robots, the robot puts on the captain's hat, the captain goes to the elevator, captain moves the chair up, gestures status report, changes state of the world, does an announcement, people playing tennis, playing golf, and then the mystery flashing button. There's a whole heap of functions that are happening behind the scenes there. And that's what we need to do as good computer scientists, is start recognizing the inputs that happen, and then the process, and then finally the output that comes out at the end. So how functions look like in Python? Well, it's pretty simple. It always starts with def. So def means define, then you name the function using usually camel case, and afterwards you can have as many parameters as you would like. Usually it's probably less than 7. Probably 2 or 3 is usually in general what you're trying to aim for. Then you have a colon or a snaky bite at the end. And then you have one statement, no statements, or many statements underneath. And then you have the option of putting a return value at the end. So that's the value that comes back, or the output So def is one of those reserved words in Python. So that's like the holy word in Python. The name of the function goes there. The list of all the inputted parameters goes inside the brackets. And this can be empty as well, so you don't necessarily need to put anything into the function. Snaky byte means the control structure has been used. Anything underneath def needs to be indented to show that it's part of that define. And then the return word is a reserved word in Python. And then the value is that value is going to be returned at the end. So this is a really simple function here. This one's basically going to go through and talk about how to add 3. Very, very simple, but it at least shows you how it works. So basically what happens is the value gets added. So we go def add 3. So that's the name of the function. And then we've got a value. We're then going to go straight to just returning the value, but we're going to add on 3 to it. So this program, when it runs, basically will add 3 each time. So this should output 7. So let's have a look. We're going to open up our idle shell. And we're going to quickly build this little function here. So I'm going to go def add 3 brackets value snaky byte. And then I'm going to go straight return value plus 3. Press enter. And then that's been stored. And now I'm going to go x is equal to add 3 and put in 4 into it. Didn't like that. Sorry, I needed a double enter, sorry. We define, and then we go return value plus 3. Then, now I go x is equal to add 3 brackets 4. Then now I go press x, it prints out 7. You could also do this as well. At the end, it's the same thing in the interpreter, which is kind of cool. Awesome. So your turn. Now create a function called multi8 that multiplies by 8 the inputted value, and then run the function with the inputted value of 6. So have a go at that. So just pause the video and see what you can do. Awesome. So what you should see when you create this is you've got multi8, and then it multiplies whatever value that you inputted by 8. So this is what you should have been able to build. So again, let's go into Python and build our own. So we'll go def multi8 brackets value snaky byte, and then we're going to return the value that we've typed in times 8. Then we're going to go x is equal to multi8 with the 6 inputted, then checked x, and it worked. Gave us 48. Cool. So now we're going to do a little bit more trickier things. So we're going to make a multi statement. So we're going to change it from Celsius into a temperature called Fahrenheit, which is what our United States buddies use. So Fahrenheit is equal to 1.8 times the Celsius plus 32. So it's a little bit different. So in anyone that uses the metric system, they use Celsius, where 0 degrees represents freezing point, and then 100 degrees represents boiling point. It's a little bit different in Fahrenheit, but you can pretty much see how that sort of plays out. So if we let Celsius equal to 30 degrees, which is like a hot summer's day, if we change it into Fahrenheit, you should do 1.8 times the 30 plus the 32, and then you get 86 degrees, which is quite hot. Cool. So to create the function to do this, we're going to use the math that I've put on the side there and try and build a little function called cell2far. So the way this works is we go def cell2far with temp, and see how I'm using words to make sure that it makes it a bit clear. And then instead of doing some logic, I'm just going to go straight to the return statement and return 1.8 times the temperature plus 32. Then I'm going to run the function. So I'm going to make cell is equal to 30, and then far, I'm going to call this function cell2far and inject into its cell. Afterwards, I'm then going to print it all out. So I'm going to print cell, and then Celsius is equal to far, and then Fahrenheit. So let's build a little function for this. Now, because it's getting a little bit more complicated, I'm actually going to make this as a script so then I don't sort of get lost as I'm building it. So first of all, we're going to define it. So we're going to go def cell2far. We're going to type in the temperature, then snaky byte. And now we're going to return 1.8 times the temp plus 32. Then to run the function, we're going to go cell is equal to 30. Bar is equal to cell to bar of cell. So the cells that we just typed in is going to be injected into that function. And now I'm going to output it. So I'm going to go print the cell Celsius is equal to bar degrees. If we save that, temp, and then we'll run it. Oh, so then you get 32 degrees Celsius is equal to 86 degrees. So I should say Fahrenheit at the end there. Let's just change that around. Fahrenheit. Cool. So your turn. Try and change this around. So instead of going from Celsius to Fahrenheit, now rewrite it so that it goes from Fahrenheit to Celsius. Now a little hint, is the math I've done here so that it makes it a bit easier. You will need to use brackets. So you will need to do Fahrenheit minus 32 first, wrapped in brackets, then divided by 1.8. Let's have a go. Awesome. So what you should find, basically this return bit here is basically temp minus 32 divided by 1.8. So if we build that code, go up here, we go def bar to cell, temp snaky byte, return temp minus 32 divided by 1.8. Then we'll go far equals 100. Cell equals far to cell of far, and then we'll print out far, brackets, far, comma, Fahrenheit is equal to cell Celsius. Save that, give it a run. There we go. Cool. So one of the key terms that you might have heard me say before is function invocation. And I always think of it like a spell. So like Harry Potter going off and calling a spell. And by calling a function and assigning a variable, we call it invocated. So in this case here, we had cell, which was set up. Invocated its far by putting cell into this function, and then that went off and activated it and set it off. So the way that sort of works, if we think about it, is first of all the program calls the copies of the arguments of to cell into the parameter temp. So whatever was stored in cell, which was here, then gets assigned into the temp here. So this is also what we would call scope. So this variable temp only exists inside of this function. Temp does not exist inside of the whole mainline function. It only exists inside here. Control is then transferred to the cell to far function, so then it gets activated. The expression cell to far is evaluated, so all the steps that are inside of it get done. And in this case, because it's just a one-liner, it just goes straight to return. So then it evaluates that and then gives that value back to far. So whatever is returned from here then goes back into far. That's pretty much what invocation means. So if we have a look here, here's the main line. Here's another way of thinking about it. There was the statement. There's the function cell to far 25. It got called. So the function then got pulled through the script to find cell to far. It then went through and did the operation and then returned that value back up into Fahrenheit. Now, I'm a really big fan of CodingBat. This is an awesome online tool for learning Python. My advice is to go through, I've done a YouTube tutorial which goes through every single one of these. Please try and master them. If you learn all of these, you will pretty much have an intermediate level of Python for your foundation. So you understand pretty much how if statements work, how loops work at a pretty decent level. And it's pretty easy to find. You just type in coding bat and then do the Python option instead of the Java option. So we're going to have a go at the first one here, which is this one. This is a pretty simple one. So sum double. And what you'll see here, actually we'll blow this up a bit so you can see a bit better, is given two integer values, you want to go through and try and work out return their sum. So unless the two values are the same, return double their sum. So sum double, it's got 1 and 2, and then that gave you 3. So just added those two numbers. However, had 2 and 2, see how it spat out an 8? Awesome. So the base case, if we go return, it's literally just A plus B. So if we go run, you'll see that it mostly works. But then this is what I love about Coding Bat. It gives you a testing ground here. So it shows you where all the expected values should be, and then it shows where the problems are. So in this case, my doubling is not working so well. So 3 and 3 should have made 6, and then 2 and 2 should have made 8 instead of 4. So what we can do is basically double it. So I'm going to do an if statement here. So I'm going to go if A is equal to B, naked by it. I'm going to return 2 lots of A times B. Now this is where it gets a little bit fun. So instead of having to write an else statement, what happens, because this is a post box, this will always be run after the fact. So if I run that now, it's done it wrong. What's happened here? It was given 18. Let's try that again. So if we go there, I was a little bit too was I? Oh, the sum, sorry. So it's plus. Just testing it there. So if we run that now, you see that I get all correct. And that's what I love about this, is it has a testing platform to show what needs to happen. And then also, if you get really stuck, you can then click on Go Solution, and then it shows you exactly how to code it out. So they did it a little bit different, and there's a whole heap of different ways of doing this. So their method, which is totally fine, is you go sum is equal to A plus B, or don't use capitals, and then if A is equal to B, making by sum, and we could be a little bit cheeky here, we go times equal to 2. That doubles everything, and then you just return the sum. There's many different ways that you can write functions, but this is why it's important to know what the inputs are, what the process needs to happen to it, and then the output at the end. So hopefully that gave you some interesting ways. I wrote this originally as well, so there's another way that you can do it. So if A is equal to B, return A plus B times 2, else return A plus B. Pretty cool. So the return statement is used to show the value that is returned by the function. So this statement is optional. You don't need to always return something. If no return statement is used, we don't actually call it a function. We call that a procedure. And a procedure is really simple. It's usually used for text displaying. So for example, if you had a game and you wanted to print out the game rules for that adventure game that you guys set up at the start, you can literally have a whole heap of prints, and then there was no inputs or there was no outputs. It just did that process. So when running that print games rules, it doesn't actually have a return statement necessarily. It just does all those actions independently without giving something back. Pretty cool. Awesome. So coming back to the even example, now this should make a little bit more sense when we try and build it. So we're going to try and build something that's going to test the function to determine if the number is even, and then test the first 10 numbers from 1 and display the even numbers that occur. So remember, if we do 4 mod 2, that should give us 0. So if it's even, it should be equal to 0. If it's false, you should get if it's odd, it should then give you a false. So here's how I coded it. So def even with a value, and then if value mod 2 is equal to 0, return true, else return false. And then I had a for loop that went through from x from range 1 to 11, And then inside that, I nested it and had if it's even, so x was even, print out x is even. So let's code that up together so that you can see it. So I'm going to use the temp one here again. I'm going to go def even with the value, snaky byte, if the value mod 2 is equal to 0, snaky byte, return true, else snaky byte, return false. And notice the true and false have to have capital letters. Then I'm going to do my for loop. So for x in range from 1 to 11, snaky byte. If it's even, snaky byte, we're going to print out x, comma, is even. So now if I run that, we should see that down the bottom there. This goes all the way up to 10. Now this is what's really cool about this function. If we now want to do the first 100 numbers, it now can go through and do all those really, really quickly as well, which is pretty cool. And all you had to do was change the range inside of the function. So then another thing to think about is you can actually just return the truth statement of what you were checking here. So this is a common mistake a lot of programmers do when they start. This is checking to see if this is true. So if it's true, return true. If it's false, return false. So instead, a really good trick to do is you just return that statement. And instead of having to write out 4 lines, you can now get exactly the same output in 1 line, which is pretty cool. So now if I run that, it does exactly the same thing. So by doing this, what happens is it returns the value of this. So this is always going to be evaluated and checked to see what it is equal to. So it's either going to be true or false, and then that gets outputted back. So have a go now, see if you can actually change this around. So instead of an even number, now check to see if it's odd, and then print out the first couple of odd numbers. Cool. So make sure you've changed the name of the function to odd. Hope you've enjoyed that. It shouldn't have been that hard. So now, instead of what you did before, you go def odd value, and then if value of %2 is equal to 1 instead of 0, return true, else return false. And then for x in range 1 to 11, if odd of x, print x is odd. So I'm going to type this up. So we're going to go def odd value, snaky byte, if the value mod 2 is equal to 1. Actually, I'm going to be a bit lazy here. I'm just going to go return. So that's my odd function all sorted. And then for x in range 1, 11, snaky byte, if odd x, snaky byte, I print out x is odd. Save that. Let's give it a run. Perfect. Cool. So now a little bit harder. What we're going to do is create a function to do my round. So there is a built-in function called round inside of Python. We're actually going to work out how does it do behind the scenes. So we're going to round to the nearest integer. And the way that we do this is we test the following values. We're going to test 26.7, 4.3, 8.5, and 117.9. So some hints here. If you do 4 mod 10, it gives you the whole number. So it actually shifts that decimal place around. So if you had x is equal to 4.5, and then you did the int on that, it gets rid of the decimal point and then just gives you that value. So pause the video, see if you can use those 2 bits of information and actually code this up yourself. Awesome. So what you should have found is something like this, which is what we saw originally way back at the start. So basically what you do is you times the value by 10, which then shifts the decimal place across. Then you do mod 10, which will then give you a value from 0 to 9. So it actually gets you to see what that decimal place value is. If that value is less than or equal to 4, then you return the integer part of that value. Else, you return the integer part of the value plus 1. So let's build the code. So we're going to go def my round of a value, snaky byte. And then if the value times 10, which shifts the decimal place 1 to the left, and then I mod that by 10. So then that then gives me the values from 0 to 9. If that value is less than or equal to 4, snaky byte, I'm going to return the integer part of the value. So just the whole part. Else, I'm going to return the integer part of the value plus 1. And then now we can test it. So then I'm going to print out my round on 26.7. Then I'm going to print out my round on 4.3. Then I'm going to print my round 8.5. Then I'm going to print my round 117.9. Awesome. So save that, give it a run, and bam. How cool is that? So it's gone through and rounded all those different values, which is really, really useful. Cool. So some conclusion questions that you should think about. Basically, how could you use functions in real-world applications, like in your game or in an application? Can you think of a daily task that could be simplified by using the Python functions? And how might an understanding of functions help you with your future programming languages or any of the projects that you're sort of going to do? So there's a Kahoot there, really handy to do. And one of the things I'd really like you to try and do now is for homework is try and build your own function. So think of a math problem like Pythagoras or compound interest, and then have a go at trying to do the homework. I'll give you an example of what I did with compound interest. So here's my function. So it takes 3 inputs, a principal, a rate, and a time, and then returns the total amount of the compound interest. So def compound interest with principal, comma rate, comma time, and then I just return the principal times 1 plus the rate to the power of the time. Now that's a pretty simple function, but that gives you some insight of what you could do for your homework. Really handy to do, gets your head in the game of using def, return, and how the parameters sort of look. So hopefully that's given you some ideas of how functions work in Python. If you do have any questions, please put them in the comments below. I'm more than happy to try and answer them. And yeah, hopefully you've enjoyed that. And if you did enjoy it, please give us a like and subscribe down below, as it does help with that YouTube algorithm. So thank you very much. Hope you've enjoyed. See you next time on STEAM with Steve. Adios.